This is T2. Calculate the radial heat current if conductivity of material is K. Radial heat current. So how does the heat current will flow? It will flow radially like this. You have to revise all different structures. All means how many are there? Some 4 or 5 are there. So just recollect all once the mathematics involved. If a like a tapered rod, tapered cylinder. So we have that one. Now let's get into what is the surface structure you should assume. You should assume a thin cylindrical shell, no? Inside this, a thin cylindrical shell has to be assumed. Now, first, what is the resistance of that? Now, first we'll go for is equal to dr equal to L by Ka. So L by K. So what is the thickness of this? Let it be d small r. So this is what we have done. Of course, this will be a cross-sectional view. What you're seeing is 3-dimensional. This is a cross-sectional view. Ria. Fine. Think all. Can you hear me?
Yes, sir.
Can you hear me?
Yes,
Yes,
sir.
sir.
We don't know what's happening. Okay, let's continue. Now these are things. Let me come first. So I think the calculate the radial heat current if conductivity of material is K. Okay, now we know resistance. So what is the radial heat? H is equal to delta T by R. So T1 minus T2 by R. Substitute R, you'll get that one. That's the first part of the problem. Come for second part. A cylindrical pipe of length has 2 layers of material of conductivity, K1 and K2. If the inner wall of the is maintained T1 and outer, calculate the radial flow of heat. How the heat will flow? Radially outward. So how the heat I think will be same same amount of heat will pass through both, no? The same amount of heat Look at this diagram, no? The same amount of heat will pass through. So they are series or parallel. Definitely they're in series. Same amount of heat. So what is the resistance of that? So first of the inner one. So shall I call this is A and B? So what is RA? Should be equal to 1 by 2 pi K1L log of R2 by R1. RB 1 by 2 pi K2L log of R3 by R2. And how they are? They are in series. So delta T by R1 plus R2. Getting the idea? So somehow I think in exam objective question, if you know this formula, it's well and good. No, straight away you can pick up options and wind up. All that mathematics, what we get by integration, please do work out. Can we calculate the temperature of this interface? How to calculate the temperature of interface? Yes, that can also be calculated. So at the same heat flows, so T1 minus T by R1 should be equal to T minus T2 by R2. Solve for T to get the required answer. 2 pi KL will get eliminated, so that T temperature of interface will be log of R2 by R1 equal to T minus T2.
The thermal conductivities are different.
Different, okay, I'll write K1, K2. Solve for T, you'll get the required answer.
Numerator it will be, sir, K1 and K2.
R is equal to 2 pi 1 by 2 pi K. It will come here, no? Yeah, okay, then thank you for correction. Solve for T, you'll get the expression for temperature of interface. So what is this T? Temperature of, very important. It appears very small, very silly, simple, but see, you have to come out of your egoism. The students will happen, they'll compare everything with mechanics. Not like that. Only in mechanics what happen, I can keep on solve new problem, but other topics are confined. So there's some threshold is there. Once you that reach that threshold, it's over. I'll scroll down.